Hello everyone, my name is Sayeda Dania Nizami and welcome to my Java programming tutorial. In this video, we will go over basics in programming, what programs are, what programming languages are, and why Java. So first I will jump on to what is a computer, like starting from really basic, what is a computer? Computer, from my point of view, computer is a machine asking for instructions. So if human is not giving instructions to computer, computer is an empty machine. So without instructions, that computer is an empty machine. Computer consists of hardware and software. What is hardware? Hardware is anything you can touch and feel, like keyboard, mouse, processor. All of those things are hardware. Even when you open a processor, you have motherboard, RAM, all of those things. Everything counts as a hardware because you can touch those things. Now, what is the software? Software are the things which you cannot touch. So, in other words, I would say softwares are a program, piece of instructions. Whatever you are seeing on your screen and you cannot touch. For example, if you are opening your pictures, if you are opening different folders, if you are opening Facebook, any other website, and you cannot touch those things, right? So all of those things are softwares, and softwares are programs written in many different languages. So in what different languages, what programs are, let's take a look and why programs are important as well. So programs are like piece of instructions which humans are giving to a computer. Hey computer, do 5 plus 10 for me, and computer do 5 plus 10 and give you the result, right? So how computer understand you? There are different types of programming language. So when it comes to the types, you have a low-level language, medium-level language, and then high-level language. Low-level language is computer understandable language, also known as machine language. So if you take a look at a given example in front of you, 11011, that is a low-level language. Low-level language is machine language, also known as binary language. Binary means 2, means 0 and 1. So machine only understand instructions given in zeros and 1. That's it. So if you are giving 5 plus 10, even on your calculator, that calculator is a machine, right? That machine don't understand what 5 plus 10 is. Computer only understands machine language or low-level language, or I would say binary, zeros. And then we have a medium-level language, which is assembly language, which use symbols to represent. So if you take a look at the given example, add, you are understanding what add is, R1, R2, R3. So this is an example of an assembly language. So assembly language use symbols, like you are understanding half portion of that statement, right? You know that this statement is doing addition of like 2 numbers. So this is assembly language. Then it comes to high-level language, which is also known as human understandable language. So whatever you are writing code on the computer or any other software, you are understanding because you are writing those things are whatever you write on the source code, that is a high-level language. A given example is in front of you. So if you want computer, or if you're writing a program to find area of a circle, like this is the formula, these are the numbers, and calculate. So this is, you are understanding it as you are reading it, right? So that is a high-level language. Now, so there's a problem right now. We understand high-level language as a human, computer understand machine language, zeros and ones, that's it. So now how to communicate with that machine? How you will be telling that machine, hey, find the area of a circle, this is my statement. And computer is like, what? I have no idea what that 5 is, what that star symbol is, and what I have to do with those things, right? So just like a normal life, we understand a different language and machine is understanding a different language. So think of an example like from a real life. There are so many languages around the world other than programming languages. We have, like, for example, there's a Chinese person, right? He understands Chinese and I understand my own language, and then there is a language barrier between us. How to communicate, right? So we need an interpreter, right? So what we do is we have an interpreter who knows both of the language. So he translates Chinese to me and then my language to that Chinese person. So same we have over here in programming languages, we have interpreter and compiler. So what interpreter and compiler does, I will explain you in a little bit. So these are some of the examples of high-level languages in the past. So it's kind of a history how we have evolved in the programming languages scenario. So we have Ada, Basic, C, C++, C Sharp, COBOL, Fortran, Java, Pascal, Python, Visual Basic. Most of you may be familiar with some of the languages, but we will discuss Java in this course. So Basic was BASIC. It's for beginners all-purpose symbolic instruction code. It was designed for beginners. It was just like by the name Basic. It was really basic language. Then we had C. C was functional language. Then we had C++, which was built on top of the C. C++ was object-oriented language, just like Java, and I will explain you the difference of both in a little bit. Then we had COBOL. That was common business oriented language used for business purposes. Then we had Fortran, that was for formula translation. These are like all these languages were all in the past, and now they are rarely used. In most of the companies still use Ada or they use Pascal, but because their old system is based on those languages, so that's why it will take a while to move on to new languages. Ada, the first language name written, it's after Lady Ada, who was the first female programmer. So, and then we have Visual Basics, still used, I think, and I think it's taught in different universities so far as well. Now let's jump on to what we were talking about, high-level language and to converting into low-level language. We have interpreter and compiler. Both works the same, both does the same thing. Translate one language into another language and then translate the other language into the first one. So if I am sending instructions in high-level language, that interpreter or compiler will translate that language into machine language, and then whatever the result is, it will translate back that result into high-level language. So what's the difference between interpreter and compiler? Interpreter translate line by line, while compiler translate the whole thing as a whole thing, right? So interpreter reads statement, one statement from the source code, translate into machine code, and then it goes line by line. So if there is an error on line 2 and I have 50 lines of code, interpreter will stop right over there. It will first ask me to fix that error, and then it will start back again from line 1 and then translating back, looking for the errors and compiling the rest of the things. So now we have compiler. What compiler does, it compile the whole thing, the whole source code, and then at the end show me a list of errors. Hey, you have these kind of errors on this line. Go and fix those errors. So basically they do the same task like translating. Every programming language has a compiler and an interpreter. Maybe they are using a compiler or maybe they are using an interpreter depending on what language you are using. Okay, so now we have understood the concept like how the programming languages work. We understand a different language, machine understand a different language, and how we are communicating. We have a compiler or interpreter between us who is translating our instructions to machine and machine instructions back to us. Machine instructions are the results of what we have asked machine to do. Okay. Now we have a little bit of like operating system. This comes to the software part. So operating systems are also instructions. So without operating system, your computer, you cannot run any other software. So operating system are, so if you're using Windows, you have a Windows operating system. If you're using Apple computers, Mac computers, you have Mac operating system. Then we have Linux. So these three are the most popular. Otherwise we have Ubuntu and Unix operating system. Okay, so the question is, why Java? We had so many languages. So if you don't just, let's not talk about all the previous, because as we already know, they were very old. So they may have flaws, they may have errors, they may have some problems. But C++ was the latest language, which was the object-oriented language. So many errors with C, because with C++, we move to the classic object-oriented concept. The object-oriented concept is like, you just give a blueprint of one thing. So for example, if I give you a blueprint of an iPhone, so I designed a blueprint of iPhone that this iPhone will have, let's not talk about iPhone, just talk about iPod. iPod have unlimited features, like you can play songs, you have a volume feature, you have a battery life, and then you have a playlist, right? These are the features, limited features, 3 to 4 features in my iPod. Now when I am giving iPod to the whole, like in a class of 30 students, every student will play a different song at a different volume. Maybe one student is playing that iPod the whole day, maybe one student just played 1 or 2 songs, and maybe one student didn't touch that iPod at all. So everyone will have a different battery life as well. So all these are objects. The blueprint is the class. So this is the object-oriented concept. What object-oriented? It's a little complicated. You will understand like after a couple of my videos on Java. So just think of object-oriented as it has reduced the redundancy part. So why Java? Java is based on basically like came after C++. So C++ had a little bit of errors, I would say, and Java is much better than C++. So if you take a look at your cell phones, if you are using smartphones, if you have applications like all the apps on your smartphones, that's all because of Java. So Java is a general purpose programming language. Java is an internet programming language which has resolved so many issues. So these are a little bit about Java. So nowadays everyone can create an app. So app on their own computers, right? On your own phones, anything you can do, and it's so easy. It's all because of Java. So Java is used to develop applications for web servers, develop application for handheld devices. Handheld devices are your cell phones, like if you're using apps, shopping apps, any other games you're using on your cell phone, that's all because of Java. Applications running from a browser, develop standalone applications, and these are some of the characteristics of Java. I will go real quick on this one. Java is simple. So if we talk about C++, again, Java is much better than C++, and they say that they have just copied C++ and said that Java, and we have worked on the errors, but it's just like a copy of C++. Java is object-oriented. Java is object-oriented concept. So again, the blueprint part, the blueprint and the objects, Java is distributed. So when all the computers are connected to a network, when you talk about networking, like, right, so when you are sending information over the network, all this is because of Java. Java is interpreted. So as you already know, we are using JVM called bytecode. The bytecode is machine independent and can run on any machine. So with the past language, the problem was, for example, if I have created a Tetris game using a Windows operating system and I gave it to my friend who used Mac operating system, that code will not run. So, or that software, that game is a very small example. If I have created any software, so the other person have to use the same operating system to run the same machine. So that's why we have Java. Java is interpreted, so it doesn't matter if I create a software on Windows or Mac, it's machine independent, so it can run on any machine. Java is robust. That's the feature because of it can run most of the compiler errors at first, and then it can also tell you the exception handling during the runtime. Java is secure. That's why it's an internet language, and it has a lot of features on that as well. Architecture neutral, again, about any operating system. These are all the features. So popular Java IDEs is NetBeans and Eclipse. For this course, I will be using Eclipse, so there will be the next video in which I will tell you how to download Java JDK and Eclipse. So just wait for that. And this is a simple Java program, where you have a class, public class welcome, then you have your main method statement, and then you have your welcome Java statement in which you are printing. I will be discussing all the small each and every detail about this code, like a very simple code, in my next video. That's it for today. Thank you. Bye bye.